we'll go over that as well. So this is on page 37 in your booklets. So I'll just use the formula for this one, right? So insert letters as needed, right? So A to C and C to D and D to B, right? So I don't know if you want to just give this a try, just to review. This should be a slam dunk. Like you should be able to just get the marks here if you're careful enough. So from A to C, you count, right? 1, 2, 3, 4, 5, 6, 7, 8. You can't go straight to B, all right? You got to go from A to C. So you have 8 factorial, and then it's 4 and 4, right? So that's 1. And then C to D, it's 6. You can tell that it's 6 steps, 3 and 3. And then D to B, 1, 2, right? 3, 4, 5. And it's 2 factorial, 3 factorial. These two should always add up to your numerator. Loris, do you mind turning off the frame for me? Thank you. And I'm just going to peek up here. 8 factorial is 40,320. 24 and 24, right? 6 factorial is 120. No, 720, sorry. 720, and then 3 factorial, that's basically 36. Why don't we just write down 36? And then 5 factorial is 120 over 2 times 6, which is 12. We know that's 10, right? 720 divided by 36, that's 20. And that one I will need some help. 70. 14,000. There you go. Now that's a lot of ways to get there, right? So here you go, page 37. Now you have the answers to both of them, all right? Let's continue with combinations. And yeah, the challenge might be for you to try to do it the counting method, right? Use the counting method. They should jive. A lot of you did both, just to confirm, right? So that was a good, I think that's good practice. Okay, so let's go to combinations. We were going all the way to page 45, all the way to 45, and we started to talk about when are we using combinations, when are we using permutations. And the key word you need to look for is, does order matter? Is there some kind of indication that placing something in a specific spot, right, would that make a difference in the term? So arrangements for pictures, right, like moving cars, like when they're parked in different ways, like those would all be different arrangements. But when you're making groups, or when you're picking lottery ticket numbers, or selecting members for a committee or a team or a hand of cards, all of that indicates combination, because really, whereas permutation would consider the order as different, these are all 6 different permutations if you consider 3 people. Combinations considers all of these as just one group. It's the same group. So that's why the formula looks different, right? Can I just add that to the bottom of this page? If you go NPR, that is n factorial over n minus r factorial, right? Versus combination, NCR is n factorial over, you first have the r factorial, and then it's n minus r factorial. Okay. So you're, when you're using permutation, remember, no repetition is allowed, right? That's implied. But the key difference here is between the two is that combination has that, divides out repeated permutations, right? To not account for all these 6 as different, right? So that's where that comes in. So I want them down here. Did I talk about the bracket notation for combination? I mentioned it briefly that instead of NCR, it could just be NR like this. It still means the same thing. R factorial n minus R factorial. Make sure you have that on your study sheet, right? They mean the same thing, okay? So just a variation of this. For tests and stuff, I personally go with this, but the textbook does use this notation. Okay? All right, are you awake already? Wide awake, Mr. Erickson. I'm ready. Okay, here we go. Simplify by hand. So I skipped this yesterday. I just want to quickly. There's not much to it really. If you see 8C5, right? It's just this 8 factorial over 5 factorial, and then it's 8 minus 5 factorial. So sometimes I'll ask you to do this by hand, which means you have to actually show me how things are canceling out. That's what that means. Okay. So let's clean that up a little bit. We end up with 8 factorial over 5 factorial. 8 minus 5 is just 3 factorial, right? So that would be step 1. Like clean it up, get rid of subtraction and all that, and then expand in order to cancel. So I'm going to expand 8. I'm going to continue this down here. 8, 7, 6, 5 factorial. I'll stop there because this 5 factorial will cancel out nicely there. And then the 3 factorial, you spread that out. You expand that. Okay? You expand. But these two cancel out here. And, here's highlighter. The highlight of the day, right? Just to show what went with what. So you can see that the 3 and the 6, right, they have common factors. In fact, 3 goes into both of them. So I will do this. And noting that the 3 goes in there once, the 3 goes in there twice. Okay. And then both of these are even, 8 and 2. So these two kind of simplify, right, to just the 2 goes in here once, the 2 goes in there 4 times. Okay, until you can't go any further. Okay, so you're left with 4 times 7 times 2 in the numerator, and the denominator is all 1, right? So that you should be able to do, right? This is 8. 4 and 2 is 8 times 7 is 56. Okay. Oh, and great news, guys. Isabel, sorry, I'm going to give you the credit, but I think it's Miss Yosik that taught this to the class. So there's a shorter way to access all those permutation combination factorial. You ready for this? So you got to press alpha and then window. No, yeah, alpha window. And right down here, so 7, 8, 9 are where you're going to find it. So let me show you again. Alpha, the green button here, and then window, and that's where you access NPR and CR factorial. Okay? Thank you, Isabel. Yeah, that's awesome. Anyway, so let's use NCR, right? So you copy that, and we want it to be 8. You want to check if you got this right. You want to check if you got this right. So that's 56. Whew, right? We got it right. So I'm not going to do NC4 because I just put a bunch of examples in here just in case. Let's do it one more time for 10P3. So you need to know the difference. It's permutation. So this will look like this. 10 factorial over 10 minus 3 factorial, just using the formula. So that's 10 factorial over 7 factorial. This is actually slightly easier, right? So 10, 9, 8, 7, stop there, cancel out, oops, my bad. So, right, 10, 9, 8, 7 factorial, cancels out with the 7 factorial, and that's all you can do really. 9 times 8 is 72 times 10 is 720. And in this case, we don't have units because it's just, there's no context. But you should be able to make a word problem out of it. Yay, right? Can you make a word problem out of them? So I'm actually going to do that down here. create a word problem. But we're not going to go A and D, we're going to go A and B because we didn't really do these two. So change that to B. Sorry guys, you're the first group that sees this booklet, so there'll always be some kinks and some changes, as you can tell. Create the word problem. So for A, right, A is a combination, right? Order does not matter, okay? So when you make your word problem, you'll say something like this. A coach needs to select 5 members from 8, right? You have 8 available candidates and just 5 make the team from 8 available players. Okay, so that's how you would word. Sorry, it's a bit small, right? I apologize. But just make a note that it is a combination. So order will not matter in this case. So a coach needs to select 5 members from 8 available players. That's as easy as it would be, guys. Don't make it too fancy, right? For B, permutation is a permutation. Order matters. Okay? So here you would say, and remember it's 10P3, so you have 10 available options and you got to make 3, you got to pick 3 at a time. Okay? So we can say, let's use the coach idea. A coach makes a team of 3, right? With a captain. No, let's not do that. Let's do with a defender, center, and offense. Okay, so there's your 3 positions. It does matter, right? Specific positions are mentioned. You could have also just said, you know, there are 10 people running for president, vice president, and treasurer, right? And how many ways can this be arranged? Just mention specific positions. That's kind of like your way into permutation, right? Because it does matter. Order matters. Oh, hold on. A coach makes a team of 3 with a defender center out of 10 players. Okay, that's important. Like you need to mention the 3 and you need to have the 10 show up there. Therefore, right, I'm going to go NP3. Okay. And this one here is out of 8 available, you have to choose 5. Okay, just to make sure you understand that. So I want to make something very clear. You might feel a little overwhelmed because I'm dumping something new on you, right? But this is just the last little tail of this unit, like doing combinations where you're making teams, hands of cards and stuff like that. So we're almost there. Just hang in there, okay? And I will use that quiz to review as well, to review those concepts. And if I don't get through the whole thing today, I will continue with that on Monday. I actually saw, you will disagree with me, okay, when you get yours back. Some of you might be like, oh, but I actually saw a lot of hope. You were getting there, but you didn't quite make it to the finish line. You were stuck a little bit, and I'll get you there, okay? You just have to do your part. Make sure you got to promise me that you're going to do your part, okay? What does that mean? Sit down, do a few examples. It does not mean I really want this and I really like it. I know what I'm supposed to do, This is good. I'm going to stop here. That's not good enough, right? You need to try a few, okay? Let's keep going. We talked about the ice cream cone on the back side here, whereas the flavors do not matter. The order doesn't matter, right? Order does not matter, so it's just a combination question. Then we started to talk about making teams, right? You have some juniors, seniors. This will whatever the two options are, you're making teams of 4. And so when you had no restrictions, then you would just take the 9 out of the 9 available individuals. You make 4 teams of 4, so 126. So this is basically the universal set, guys. Do you remember the universal set? It's all possible arrangements that can be made in this case. What if you had to have exactly 2 juniors on the team? Well, you're still making teams of 4, so you had to have 2 juniors and therefore 2 seniors. A lot of students forget that part. They just focus on the juniors, right? It's like that. I'm just going to answer that question. Remember, you're making teams of 4, teams of 5, teams of 6, whatever I give you. So this is review, I know, but I kind of rushed yesterday, so I want to make sure you get this part. So we ended up with 60 teams if 2 exactly, watch the word exactly 2. And then exactly 3 seniors, we did the same thing. If we have 3 seniors, we must have a junior to complete the team. So from the 4 seniors, we chose 3. From the 5 juniors, we chose 1, right? The 3 and the 1 are highlighted, and 20 teams could be made that way. This is where it turns. This is where it turns, so now wake up if you're not awake already, okay? If you want a bucket of cold water, I can get that for you. Anyways, the walk outside does the trick, doesn't it? I wake right up in the morning. At least one junior, that's very important, is on the team. Use direct and indirect reasoning. What in the world are you talking about, Mr. Dirksen? Here it is. At least one junior means, right, 1 junior or 2 juniors or 3 juniors or 4 juniors. Would you agree with that? Okay, if you have at least 1, that means that this is really what the question is saying. Okay? So bear with me here. I'm going to actually make sure I have my notes right in front of me because I want to get this right. So what we're going to do here, and it's a little tight. The space is tight, so you gotta just kind of write small, okay? So we're going to go 0. If you grab 0 juniors, right? How many seniors must you have? 4, because you're making teams of 4. So 1 junior, 3 seniors, correct? 2 juniors. And some of the answers we will already know. I'm going to steal from the top, okay? 2 seniors, 3 juniors, 1 senior, 4 juniors, 0 seniors. Sorry. Yeah, you gotta be careful here. So I'm going to do all the cases, guys, so that you can see what indirect and direct means. Okay, so are you following? Okay, so this means, let's write this as a combination. We have 5 juniors and 4 seniors. So out of 5, we're going to choose 0, and out of 4, we're going to choose 4. Okay, remember, I have 5 juniors and 4 seniors to pick from. This case right here would be what? 5, choose 1, and out of the 4, I would choose 3. Right? So 1 and 3 making a team of 4. Every time you look at these second values here, they make a team of 4. Let's keep going. 5, choose 2, and 4, choose 2. Let's keep going. Out of the 5, in this case, you're going to choose 3 juniors, and out of the 4 seniors, you're going to just choose 1. Is that small or what? Let me do this here, folks. I want to help you out. I want to help you out there. So copy that. And then this case, out of 5 juniors, you would pick 4. And out of 4 seniors, you just pick 0. You're not going to do this every time. You're not going to do this every time. It's just now for this example that I'm doing it, okay? Down the road, you're going to do this faster, and I will do a couple more after this. Okay, let's compute this. What's 5 choose 0? I gave you a shortcut yesterday. That's just 1. What's 4 choose 4? That's actually 1 as well. And if you don't trust me, just type it into your calculator. So that's just one team that could be made in that case. Okay. What is 5 choose 1? 5 choose 1 is actually 5. 4 choose 3, it's actually 4. Okay. Right now we're not focusing because I know you can just type it. You're better than me at typing because you're texters, right? 20, right? 5 choose 2, I need help with that one. That one I don't know. So grab your calculator. I'm just going to copy the previous one or go alpha window, right? 5 choose 2, 10. So that's 10. 4 choose 2. That's an easy fix here. 6. Okay, that's 6. So that's 10 times 6 is 60. And 5 choose 3. 10. And 4 choose 1. That one you should be able to tell. What's 4 choose 1? It's just 4, so that's 40. And then the last one here, 5 choose 4. If they're 1 off, then that's the number you put down, 5. 4 choose 0, that's just 1 by definition. It's like 0 factorial is 1. Right now you just have to trust me, which is a scary thing, right? I'm supposed to trust you, you get it all wrong. You get the formulas wrong. I'll try my best. Anyway, so watch this. Now you have every possible scenario lined up. If you want to use direct reasoning, okay, direct. Can you highlight that? Direct means go straight to what makes sense, basically. So you go 1 junior, 2 junior, 3 junior, 4 junior. This would be direct. Adding all those up. Would you agree with me? Adding up all the teams that have at least 1 junior in it. So it would be 20 plus 60 plus 40 plus 5. We can do this one, right? 125. 125 teams. This is direct. Direct reasoning we did. When you're adding stuff up, you're going directly to what kind of intuitively makes sense to you. Just add up all the possible scenarios. Indirect, I'm going to use green. Indirect reasoning is different. Okay? Can we cut that here? Indirect, we're going to take the total without restrictions minus, what are we going to subtract? No juniors, right? This is indirect reasoning. And let me zoom out because you can't see that, right? Indirect is taking the total minus no juniors. What's total here? Did we already calculate that? All possible teams that can be made? 126. I'm going to do this though. I'm going to go 9, choose 4, right? Minus no juniors. We already know, if you look at the left here, I need a camera person, a full-time camera person to help me out here. Volunteer position, how's that? This one right here has no juniors. No juniors. Okay, this one, there's only one team that would have no juniors under these circumstances. So we're going to actually put this 5C0 times 4 choose 4. And now we're going to insert the numbers. We know that this is 126 minus there's only one team, this would only come down to just one. We already did the math here, so let me just, and what do you get? 125 teams. Either way, you have to get the same answer or else there's something wrong. So which one would have been faster to do in your opinion? Indirect. Indirect would have been. It's almost like, remember the question that says how many passwords have at least one repetition? And you're probably remembering that question. You got to go total minus no repetition, right? Then you get all the passwords that have one or more letter repeating, okay? So same idea here, direct and direct. Let's go the second question here. At least 2 seniors are on the team. Okay, at least 2 seniors, let's see what that means. That means 2 seniors or 3 seniors, or in this case, up to 4 seniors. It can't have more than that. Okay. Let's look at what we just did here. You just go up because you already did the work, right? You have 2, 3, 4, right? 2 seniors, 3 seniors, 4 seniors. So you can just go up here and really just add 60, 20, and 1. So I'm going to go, watch what I'm going to do. 2 seniors means that you have 2 juniors plus 3 seniors and 1 junior plus 4 seniors and 0 juniors. I don't know why I'm making my J's look so funny. I don't know what's happening. Maybe I didn't have enough coffee today. That's what it is. I normally make a decent J. So I'm going to go right, like, can we just copy this down so you know what I did here? 5, from 5 juniors, I choose 2, right? And then from the 4 seniors, I would choose 2. That would get me this part. Or when you have at least, you have cases, right? Or 3 seniors. So from the 5 juniors, I choose 1. From the 4 seniors, I choose 3. Or from the 5 juniors, I choose none. And from the 4 seniors, I choose all 4. And we know the answers already, right? This would be 10 times 6 plus 5 times 4 plus 1 times 1. Okay, so you have 60 plus 20 plus 1, and that would be 81 teams. What method did I just use here? You're adding. So this is your direct reasoning. Okay, that's direct reasoning. Let's do indirect right next to it. We're going to go total minus, we're going to subtract 0 seniors. We're going to subtract 1 senior, right? We're going to, right, because we want these to be left. So therefore, we're going to subtract these 2, right? You notice that we added these 3, so we're going to subtract these 2 from the total. So total is 126 minus 0 seniors is right here. 5 choose 4 and 4 choose 0 minus 5 choose 3 times 4 choose 1. So that's 126 minus, I know that this is 40, minus, I know that this is 5. No, sorry, I'm mixing it up, am I? This is 5, right? This part right here, I took it from here, so that's 5 minus 5 choose 3, 4 choose 1 is 40. Okay. So 126 minus 40 would give you 86, minus 5 would give you 81 teams. And you're like, Mr. Dirksen, do I have to do both? Not really, not on a test. I will let you decide what you want to do. Okay. But sometimes one is less work than the other. In this case, it's about the same amount of work. This one is a little less, right? A little fewer computations here compared to this one, right? You had more going on. But I mean, you still have 1, 2, 3, and technically this 126 you would also have to compute, right? You would also have to type that in to get that. Can I do something? No, that's going to make it too messy. I wanted to kind of highlight these ones compared to what we did up here. But then it might get... Let me try it. If it doesn't work, you're not going to do it, right? This one here, I got it from here. Okay? And this one here, I got it from here. So if you don't want to do this, just leave it. Okay. I think that's all I'm going to do, or else it'll get too crazy. But that I grabbed these two here and subtracted it from the total, okay, to get my indirect. How are we doing, guys? You still have your hair? You're not ripping out your hair, are you? I hope not. I know I should have left more room. I know I was kind of like a little upset when I went through this. I should have given you a bit more space. But something like this, you don't need to do all of them. As long as you know what you're doing, just do the ones that you need. And if you want to do it the direct way, just do this, right? If you want to do it the indirect way, but I think I would strongly recommend if you say read this and if it says at most or at least, what does that mean? At least 2 seniors means 2, 3, or 4 in this case. If it had been teams of 5, right, it would have been 2, 3, 4, or 5 seniors, right? So, and it would have been a problem because we only have 4 seniors. So obviously, I would have to change this question, right? But that's that. Come with me to page 48. I'm going to get you to take a little break, a 2-minute brain break, right? You need that. Can you read that one? And did I give you I feel like I gave you a deck of cards printout, right? For the set theory. I gave you a deck of cards. But I want to give you a little review here. Just a quick review. Write this down with me. Right? You have 26 black and 26 reds, correct? And then you have half of 26 is right, 13, 13, 13, 13. You have spades, clubs, hearts, and diamonds. And each one of these can be broken down into ace, 2 to 10, jack, queen, king. Okay. I don't know if you want to put this on your study sheet. You're not going to get a ton of cards questions, but if you're uncomfortable with like a deck of cards, I don't know. You decide what you need to do. Okay. How many face cards are there? The jack, the queen, and the king are considered face cards. So there's 3 in each suit. So there's 12 face cards. Faces. How's that? Just 12 faces. I want you to try to apply what I just did. Try to read through this and see if you could start this going, get this going. This is combination. I'm not going to lie to you. There's no permutation here sneaking in. But how would you do this if I asked you to answer some of these questions? So go for it. I'll be right back with you to practice this. Okay, how many ways can a hand of 5 cards be dealt? Hand of 5 cards, I really hope that by now you realize this is combination, right? There's no order. You're not picking one at a time, right? And what's that arrangement versus another arrangement? It's just a hand of 5, okay? Combination. Order. Why am I doing this? Why am I emphasizing that? Because soon you're going to have to pick what is the scenario here. Is this permutations, which you can also use the fundamental counting principle. Permutation, fundamental counting principle, the same thing. But with combinations, you cannot use the fundamental counting principle. You can't, because it doesn't get rid of the repeated arrangements. Okay, so in this case, you have 52 cards, and you're going to choose 5. That's it. 52, choose 5, and that's a big number. Here it is. 2598960. Hands. Always put something down for units, okay? So that is important. That is every single hand that can be dealt. It doesn't matter. There's repeats, non-repeats, everything is there, okay? What about this? You can have at most 2 black cards. You're still making hands of 5. 2 black cards, which means at most, right? At most means 0 blacks, right? Or 1 black, right? Or 2. Sorry, I'm mixing up plus or, right? But this is, let's go or, right? So that means you can have 0, 1, or 2, okay? Specifically, 0 blacks, 5 reds, or 1 black, therefore 4 reds, or 2 blacks and 3 reds. Okay, that is the implication of the 5 hand. It's almost like 5 blacks and the other ones have to be non-black cards. 1 black, 4 non-black. Think of it that way. It's not the other. Okay, so here we go. I'm going to use direct reasoning here. Some of you use indirect, that's fine. So for direct, okay, direct, we're going to go out of the 26. So I'm going to follow this as this is my kind of formula, my setup. So I'm going to 26 black cards, I'm going to choose 0. And out of the 26, I'm going to choose 5. Or the next one is out of the 26, I'm going to choose 1. And I have to, out of the 26, choose 4. So this is kind of like one scenario, or the other scenario, or out of the 26, I'm going to choose 2. And out of the 26 remaining, I'm going to choose 3. Right? So that's your setup there. So let's figure out what this is. 26 choose 0 is just 1 times 26 choose 5. Did anybody do that already? Let me check my key here. 26 choose 5 is 65,780 plus 26 choose 1 is just 26 times 26 choose 4 is 14,950 plus 26 choose 2, that's 325 times 26 choose 3 is 2600. Make a big dot always in between, okay? They're multiplying. So here we go. Now let's just type it in. So this is that. This is 65,780 plus 388,700 plus 325 times 2600 is 845,000. All of that is equal to, if you add that up, if you add up these three, you get, let me just check my notes here. I need to redo this because I changed the question on me. So 65,780 plus 388,700 plus 845,000. That is 1,299,480 hands. Using the direct method. Okay. Do you want me to do indirect? Yeah? Okay, indirect. Indirect. So we're going to go, let's set up what we're going to do here. Total, I'm going to go with total, no restrictions whatsoever. I'm going to subtract 5 blacks minus 4 black cards minus 3 black cards, right? Is that more work or less work? For some of you, it doesn't. So I'm going to go 52, choose 5 minus. I didn't do indirect in my notes. You're going to have to follow here. Okay, 26, choose 5 black cards, which means 26, choose 0 reds, right? Minus 4 black cards, 26, choose 4, which means I have to go 26, choose 1. Minus 3 black cards, 26, choose 3, times 26, choose 2. I'm focusing on the black cards first, right? And then I'm focusing on the reds right after. So this is 259,8960, right? That's this part, minus 26 choose 5 is 65,780 times 1 minus 26 choose 4 is 14,950 times 26 choose 1 is 26 minus 26 choose 3 is 2,600 times 26 choose 2 is 325. And this better be the same answer, right? Or else we're in trouble. So 259,8960 minus, this is just 65,780 minus, I did this already earlier, right? 388,700 minus this one here. Grand finale. Yes, it's the same thing. So quiet. So quiet. Anyway, so there it is. Same way, indirect, direct. Okay, you're like, Mr. Dirksen, are you serious? You're gonna do this on a test? Like, this is so much work. It's more than likely not gonna be that much work. It's probably gonna be at least one or something like that, where you're just gonna have to. Indirect is probably quite often gonna be your go-to, but both ways should work. Okay, both ways should get you there. Just look at the marks on the question. If it's 3 marks, you're like, okay, work required. Okay, let's do the hearts. For sure, I leave that. I'm going to give you the answer to that one because I want to hand out the quiz. You try this. That's part of your homework. So I will put the answer here. 953,940 hands. Sorry, that's the answer to C. Write that down. And I'm going to be here tomorrow, right? So from time to time, I'll check my email. If you have a question, let me know. As well, in the textbook, I just want to check the next page if the textbook questions are on there. No, okay, so homework, page. Now you can do more. Now, I think yesterday went I'm going to go page 280. From evaluate, those ones I don't really care much about. 5 to 12. 12 is a bit of a tricky one. So I'm going to put a star next to it. I will talk about it next week. Okay, so that's that.